All right. So yesterday we kind of already mentioned some of the special products with our algebra tile activity. These are just very special cases of polynomials when it comes to multiplying. So if I'm looking at the first part of the notes. So the first special case that we have with special products is called the square of a binomial. And all that means is that if you had a plus b squared, all right, so it's just a binomial in parentheses and it's all squared, it's actually equal to, if you multiplied it through, there's actually a formula that'll be equal to. So it'd be equal whatever a is squared plus 2 times ab, or the product of a and b and multiplied by 2, plus b squared. And on the opposite end, if you have a minus b all squared, the formula is a squared minus 2ab plus b squared. Now, another thing to note, like I said yesterday, if you have a plus b all squared, that is the same thing as a plus b times a plus b. So we did a couple of examples of those yesterday with the algebra tiles towards the end. Like we had like x plus 3 all squared, and you had to basically on both sides of the algebra tiles put x plus 3 times x plus 3. All right, so you can still do box method or FOIL with these, but if you want the shortcut, you could use the formula. So we're going to do some examples. I'm going to use the formulas for these first, and then I'll prove it that it is the correct answer with either box or FOIL. All right. So first things first, with number 13. All right. We have x plus 7 all squared. So if we think about it, it's the same thing as x plus 7 times x plus 7. All right. Now, if I'm using the formula, so like the a plus b squared equals a squared plus 2ab plus b squared, I first need to label what my a and b values are. And I'm looking specifically at this part, the x plus 7 all squared. So look at the placement from above. What do you think my a term is? So which term represents a? The x. B is what? 7. All right. They're just, what's the placeholders for A and B at this point? All right. Then I'm going to put it into the formula. So I'm just going to do it kind of individually. So for the a squared part, we're literally just doing x and then squaring it. Because x, if you raise x to the second power, that's just x squared. Now, the 2ab. This means you're doing 2 times x, which is my a value, times 7. So what would that be equal to? So do it one step at a time. What's 2 times x? 2x times 7. 14x. Good. And then b squared is 7 all squared, which, what's 7 squared? 49. Now, we're just going to take all of these different parts, put it into the formula. So my answer should be x squared plus 14x plus 49. Now, that's if we use the formula, but let's do a quick box method to check. So if I do a very quick box, so it's a 2 by 2, because remember we're doing x plus 7 times x plus 7. I have x plus 7 on the top, x plus 7 on the side. So the first box here, what am I multiplying together? So that highlighted box, what am I multiplying together? X and x. So what's x times x? X squared. What about this box? So that'll be 7 times x or 7x. This box. 7x. And then this box. So you're doing 7 times 7 because that's where the row and column aligns. So that's 49. Then remember, you pull everything out of your box, combine like terms. So you get x squared plus 7x plus 7x plus 49. These combine, you should get exactly what we got last time. Because 7x plus 7x is still 14x. So again, if you don't remember those formulas, that's fine. Just do box method or FOIL. It works either way. But you just got to remember that if you see a binomial squared, it's the same thing as this. All right, you got to remember that x plus 7 squared is the same thing as x plus 7 times x plus 7. That's the one takeaway you got to remember with these. All right, let's try another one. So let's do 15. So 5k minus 2 all squared, what's that the same as? How would I rewrite that if I broke apart the square? Right, 5k minus 2 times 5k minus 2. So you could use this and do box method or FOIL, or you could use the formula. All right. For this case, I'm going to use the formula, but just know that you could use both or either or. So I'm going to use the formula. So again, I'm going to label what my A and B values are. What term is my A value? 5k. That's the term, that's my A value. Now, you don't need to worry about signs, but what term is my B value? And don't worry about the sign. 2. And again, we're just looking at the placeholders here. So that's why we don't really care about the signs, because in the original formula, the minus is already here. So we're just going to figure out each part. So a squared, that would be 5k all squared. So that's the same thing as 5 squared times k squared. So what's 5 squared? 25. So this would be 25k squared. Then we're dealing with negative 2ab. So we're doing negative 2 times 5k times 2. So what's negative 2 times 5k? Negative 10k, and then times it by 2 again. Negative 20k. Then b squared, we're just doing 2 squared, which we know that's 4. So then I'm going to take these 3 terms and put it in the formula. So your answer should be 25k squared minus 20k plus 4. And again, just to check that I did the formula correctly, I'm going to do a quick FOIL of 5k minus 2, 5k minus 2. All right, so I'm going to use FOIL. So remember, FOIL stands for first, outer, inner, last. So that's the other method you can use to multiply. So I'll do the first. So what's 5k times 5k? 25k squared. So 25k squared. My outers. What's 5k times negative 2? Negative 10k. Inners. What's negative 2 times 5k? Negative 10k. And then my last. What's negative 2 times negative 2? Positive 4. So then I combine like terms, which the only like terms are my negative 10k's. And if we do that, we should get the exact same answer that we already got. Any questions on squares of binomials? So again, the common mistake that I see is that most people just would just square the 5k, square the 2. That's their answer. But remember, when we did our algebra tiles yesterday, we learned that that's not the case because there is some x value still in there, not just the x squared and the constant. All right. Now, the last special case is the product of a sum and a difference. All right. So, product of a sum and a difference. It's basically saying if you have a plus b times a minus b. So you have the two same terms, but one of them separated by a plus, one of them separated by a minus. The product would just be a squared minus b squared. So when we get into our factoring, this is going to be called a difference of squares. All right. A product of a sum and a difference creates a difference of squares binomial, which we'll learn about later on this next week. All right. Now, we're about to see why this works. So I'm going to do box method for number 16 so we can see why this works. So for number 16, I'm just going to do a quick box method. So we have a 2 by 2 box. I'll put b plus 3 on top, b minus 3 on the side. All right. What would I get for the product of this box? So what am I multiplying first off? The two b's, because that's what's in line, the column and the row that's aligned to that box. So we would get b squared. What about this box? 3b, because we're multiplying 3 times b. This box. Negative 3b, because we're multiplying negative 3 times b. And then finally, this one. Negative 9, because we're doing negative 3 times positive 3. Then if I bring everything out, I get b squared plus 3b minus 3b minus 9. Now, I would then combine like terms, which are right here. What happens? They cancel each other out because we're doing 3b minus 3b, which that's just equal to 0. So these two go away. They canceled each other out. So this is now, we're left with b squared minus 9, which, if you look, is the exact same as the formula that we got. Because what would I say my a value is here if I'm looking at the formula? What's my A value? So your A value would be what? B. And your B value would be what? Ignore the signs. Just 3. What's B squared? So A squared would be, if we do B all squared, what is it? Just B squared, right? And then if we do B squared, I know there's multiple B's in there, but what's 3 squared equal to? 9. It should work. I don't actually click on the link. No, sure. No, they already like log into quizzes and then log in. Okay, we have a seat, please. So we still get B squared minus 9 even if we did do the formula. All right, last one. 18. I'm just going to do the formula for this one. Just know that those x values, if we did box method, would cancel out. And this one's a little bit easier to see because there's no other b's. So what's my a value here? If we're looking at the formula. 4x is my a value because it's in the a placement. What about b? It'll be 3 because it's in the b placement. So now I need to figure out what a squared and negative b squared is. So if I'm doing a squared, that means I'm doing 4x all squared, which by power rule, that's the same thing as 4 squared x squared. And then what's 4 squared? 16. So this would be 16x squared. Then I'm doing negative on the outside and then 3 squared on the inside. So basically we're doing 3 squared multiplying it by negative 1. So what's 3 squared? 9. And then multiplied by negative 1 would be negative 9. So if we put this in the formula, or just write it out, we get 16x squared minus 9. Which, if I did do a very quick box method, and I'm just going to do this one quickly on my own. 4x times 4x, 16x squared. 3 times 4x is 12x. 4x times negative 3 is negative 12x. Negative 3 times 3 is 9. And what you'll notice is that right here on the diagonal, these are the like terms, and they're the same, except one's positive, one's negative. So these would end up canceling out. That's supposed to be negative 9. And if you pull everything else out, you still would get this. So again, guys, when in doubt, don't feel like you're obligated to use those formulas. If you are getting confused by them, just stick with box method and FOIL. It works either way. All right. I just have to show you that there are shortcuts in that case. But again, if the formula confuses you, screw the formula, use box method or FOIL. All right. It works either way. Any questions on that? All right. So